Okay. Okay, meters over second. I have to record it later. Okay, and let us pick another time from t equal to 5 to 5 and to t equal to 5.01, and what we see. Okay, the same way. Average velocity of this would be s as 5.01 minus s as 5, right? Divided by the change in time, 5.01 minus 5. Then again, we put everything into the formula 4.9 t squared, which is 4.9 5.01 squared minus 4.9 5 squared divided by 5.01 minus 5, which gives us 49.049 meter over second. And let us pick another time, right? From t equal to 5 to t equal to 5.001. And the similar computation, which gives us 49.0049 meter over per second. So we see that when t approaches to 5, right, the velocity will approach to 49. Right, the first one is 49.49, and the time distance is smaller, then it reached 49.049, and it come closer, and it approached to 49, right? So we see that, we guess that at t equal to 5, the velocity is 49 meter per second. That is what we guess, because times. Okay, so at home, please read the textbook. It's an amazing book. I love this book. About instantaneous velocity. Okay, do you have any question about this part? Oh, the Calculus 1 Stuart 8 edition. If you haven't got if you haven't bought the book, please go to website, order one. I think you are able to purchase it already. They fixed the problems. I saw some of you haven't had one. Please go that. After creating an account, remember, use your LSU email. Log into Moodle. Inside Moodle on the left side, you will see in introduction, they will have a external tool named WebAssign Math 1550. Click on that, log into that, you will be able to see the homework of our class, and your name will be updated automatically in a correct way. Okay? Yes?
When does the average velocity become instantaneous?
Yeah, when t, the distance t comes close to 5, it becomes an instantaneous velocity at that point. Very good question. But yeah.
So we were given the fact that S would be 4.9 for the problem.
Correct. That is the first law of attraction, gravity force. Is 9.8, and it will be one half of 9.8, which is 4.9. Yeah, when you study physics, they will explain you more about that. But this is good. Yeah. Any more questions? Okay. Very good. Let us move to the section 2.1 about the limit of a function. So in this chapter, 2.2, we will study the limit of a function. Okay? So how does the function behave? For values of x near 2. We know that the graph of the function will be somehow like this, right? Okay. This is y, this is x at 1, at 2, right here, -1. So, and we just found the slope of that at this point, it will be somehow like this, okay? So, we can draw a table which the value of x and the value of fx and see how it's behaved. We are asked at 2, right? So let us pick the value near 2. How about x is equal to 1.8, 1.9, 1.95, 1.999. And we don't have much space for that, so let me make a new table below. For the value 2.1, and it come closer to 2 from above, 2.01, 2.001. So now you have 30 seconds to pick any number and find the value of that. We'll fill in the blanks later. Did you all have a solution? So these are the number I computed in advance. Double check if it is identical to yours. Okay, we see that when x comes close to 2 from above, below, which value it is approaching to? 3, yes. And the similar things, when x comes to 2 from above, which value is approaching to?
3.
Yes, it's approaching to 3, right? Perfect. Hold on a second. Let me pull it down a little bit. Yes. Okay. That is what we observe. And we say that the limit of fx as x approach to 2 is equal to 3. That is what we say, right? Okay. And definition of this, I think the best way is to read the textbook that will explain to you in more details. But let me just shortly write it down. We write it limit of fx is x approach a is equal to L. It means that, okay, the limit of fx is x approach 8 is equal to L. Yes. I'm sorry? Oh, I'm sorry. Okay. Lim or limit. You're welcome. This is the definition of it, right? Remember, x x is not a. X is not a. And the function fx need not to be defined at x equal to a. And another thing is x approach a means x approach from both sides. Okay, those are things we need to care. And so suppose we have the graph like this. Okay. See, in the first figure, oh, is it too small for you? Is it better? Yeah, the first figure here at x is equal to a, then the value of fx is L here. And this point does belong to the graph here, right? Or at this point here is a hole. There's a hole right here. It's not a solid point. So the value of function at A is defined at this point here, the solid point right here. Whoa. That is where this point, f of A is equal to this point. So you see the line here is disconnected at this point, right? And another case, for example, it may happens is this is a hole at this point, and the function is not defined at A. We don't know what value of this. So, but they all have the same limit. When x comes close to A from above or below, they will have the same value, f of limit L. So these are three situations, okay? Very good. Now let us consider again, what is it? Okay. Okay, now go back to the previous example at chapter 2.1. There is a equation of the slope. Now, guess the limit of lim of x squared minus 4 divided by x minus 2 when x approach 2. Okay. In the previous example, we computed the value of, did we? Oh no, we just found that the slope is 4. Okay, now what we can do now is to make a table. X value and f of x, right? We need, let us say, 1.8. Let us go with 1.9, 1.95, 1.99, 2, 2.01, 2.05, 2.1, and 2.2. Okay, now every one of us use a calculator to compute any value you like and see if how we can find it. Okay, now these are value I found. 3.8 if x is 1.9, 3.9. Oh no. It is 3.9, 3.95, 3.99. And 4.01, 4.05, 4.1, and 4.2. What is the value of the function at x equal to 2? It's not defined, right? When you put x is equal to 2, the denominator becomes 0. And it is not defined that way. So we see that when x comes close to 0, what is the limit of this? Which value is it approaching to? 4, right? Therefore, we say, we say that the limit of x squared minus 4 divided by x minus 2 when x approaches to 2 equal 4. That is what we find. Very good. Okay? Now, let us extend our problems a little bit. This function is not defined at 2, right? So let us make an example. What is the limit of fx when x approaches to 2, where f of x is x squared minus 4 divided by x minus 2 for x different from 2, and the function fx is equal to 1 whenever x is equal to 2. So this function is branch function, right? There's 2 branch. Whenever you plug into any value of x, consider where it belongs to. If it is different from 2, then we follow this formula. If it is equal to 2, then we follow the second branch where fx is equal to 1. That is branch function. So now we know that from the previous example, limit of fx when x approaches to 2 equal to 4, right? But in this case, the way we define the function f at 2 is equal to 1, right? From definition here. We see that limit of fx when x approaches to 2 is not equal to f at 2. This is a remark we need to care. Okay? So I think we're good for today. I will record a short videos of the very beginning of this because I forgot recording it. And I will quickly discuss the one-side limits and vertical asymptotes because we are behind the schedule due to the hurricane. So I will try to upload and notify you when it's available. Please do it. I have already extended the homework due date for 2.1 to be next week. Okay, have a good weekend. Stay safe. See you. Have a good day. Thank you, you too.